Hi, in today's video, we're going to solve mechanics paper 43 from May June 2022 series. Okay, question 1 is about momentum conservation, and I'm going to draw the diagram first. So we have two particles, P and Q. Mass of P is 0.3 and the mass of Q is 0.2 kilograms. Now P is projected with velocity 4 meters per second. Then after the collision, Q starts to move with velocity 3 meters per second. And we have to find the speed of P after the collision. Okay, we're going to use momentum conservation, so momentum of P is going to be 4 times 0.3 initially, and then momentum of Q is 0 because it stays stationary. Now, after the collision, the particle Q moves with velocity 0.3, so it's 0.2 times 3 plus 0.3, that's particle P, times its velocity. And from here we can find V. So we got 0.3 V equals to 0.6, and then from here V equals to 2 meters per second. Okay, next question, I will draw the diagram again. Now the particle Q continues to move with a velocity 3 meters per second, and its mass 0.2, and then it hits a particle R, mass m, and then after the collision, they combine together and make the particle of mass m plus 0.2, which moves with speed 2 meters per second. Again, momentum conservation, 0.2 times 3 equals 2 times m plus 0.2. And now let's solve this equation for m. And here we go, m equals to 0.1 kilograms. Question 2a. The particle P is projected from the ground, and it's going to reach the maximum height of 45 meters, and then goes down. Alright, so the first question, we have to find the initial velocity. And for that I will use the energy. So all kinetic energy at the initial point, which is mu squared over 2, was eventually transferred into potential energy at the highest point, which is mgh, and m cancels out. So u squared equals to 2 times gh, and we'll take the square root, and we'll get square root of 2gh. Now substitute all of that, and we'll get square root of 2 times 10 times 45, and that is going to be 30 meters per second. Okay, next question, find the total time for which the speed of P is at least 10 meters per second. So now what happens here is that the particle is being projected with initial velocity 30, and as it goes up, its velocity is decreasing. So now at some point, its velocity is going to be 10 meters per second. And then it will reach the highest point, it will start falling down, and then at some point again, its velocity is going to be 10 meters per second. And after that, it's going to accelerate towards the ground. So now what I'm going to do is to find the time it takes to go from 30 meters per second to 10, and then we can multiply by 2 because the path of the particle is symmetrical. And for that, I will use the formula V equals to U minus, well, technically it's plus, but our particle is decelerating, so therefore minus. So 10 equals to 30 minus acceleration is 10 times time. Let's rearrange this, and we'll get t equals to 2. But that's only the time to go from 30 to 10, so it's this time, and then I will have to multiply by 2, so therefore 4 seconds. Alright, next question is about the graph, and a particle passes points P, Q, and R at times 5, 10, and 15, So instead of calling it A, B, C, and D, I'll just call it O, P, Q, and R. Okay, so first we have to find the speed of the particle between t equals 5 and 10. So we know that the distance OQ is 150 and the distance OP is 50. So overall the distance from P to Q is 100 meters. And the time would be 5 seconds. So velocity is going to be 100 divided by 5, which is 20 meters per second. Okay, and for question B, we have to find the acceleration between 0 and 5, given that it's constant. So we know that the distance OP is going to be 50, and I will use the formula S equals to UT plus AT squared over 2. Distance is 50, and we start from rest. So 0 equals to A over 2, and the time is 5 seconds, so it's 25. Multiply both sides of the equation by 2 and get 100 equals to 25A. Now divide by 25 and A equals to 4 meters per second squared. Okay, question C, we have to find the average speed of a particle during its motion. So average speed is going to be total distance over total time. Now let's look at the graph. So in terms of distance, the particle went from 0 to 200 and then went back to 0. So all in all it went 200 plus 200, which is 400. And the time it's taken was 20. So all in all we got 400 over 20, which is 20 meters per second. Okay, question 4a is about equilibrium, and we're going to choose our x and y axis first. I'll say this is y, and x is going to be horizontal, of course. And we're also given the length of each string, and we're giving that in order to find the angles. So I will call those angles alpha and beta. And looking at alpha, we can find tangent. So tangent alpha is going to be opposite over adjacent, so it's 0.8 over 0.6. Take the inverse tangent, and it's about 53.13. And knowing those sort of questions, I will calculate sine alpha and cosine alpha straight away. And the same for beta. We can find tangent beta first. 0.6 over 0.8. From there, beta is equal to 36.8. But then we just need sine beta. It's 3 over 5, and cosine beta 4 over 5. Okay, this angle here is also alpha because z angles, and for the same reason, this angle is also beta. Now the particle is in equilibrium, so that means we can resolve on x direction and y direction, and then the sum of all forces should be equal to 0. I will call tension T1 and T2. The mass is 10 kilograms, so therefore the weight is 100 newtons. And we know that the force equals to 20. Okay, so let's start with x-axis first. So we got F, and it has the same direction as x-axis, so I'll take it with the positive sign. We also have the x component of T2, so plus T2, and the x component is adjacent to the angle, so multiply by cosine alpha. T1 is in the opposite direction of x-axis, so I'll take it to the negative sign. And again, the x component of T1 is adjacent to the angle, so therefore cosine. And these are all the forces acting on x-axis. It's equilibrium, so the sum equals to 0. And the same logic applies to y-axis. So T2 is up, so is y-axis, so therefore positive. T2 sine alpha plus T1 sine beta. And then the weight is in the opposite direction of y-axis, so it's minus 100. And the sum must be equal to 0, because that's equilibrium. Now, we already know what cosine alpha and sine alpha are. So we can just rewrite our equations as 20 plus T2, cosine alpha, that's 3/5, minus T1, cosine beta, that's 4/5. That equals to 0. Okay, T2 sine alpha is 4/5 plus T1 sine beta, that's 3/5, minus 100 equals to 0. Okay, let's multiply first equation by 5. We got 100 plus 3T2 minus 41 equals to 0. And then the second equation for T2 plus 3T1 minus 500 equals to 0. Now I will move all the numbers to the other side. So minus 100 here. 4T2 plus 3T1 equals to 500. And then I'm going to multiply the first equation by 4 and the second one by 3. So I will get 12T2 minus 16T1 equals to minus 400. The second equation will be 12T2 plus 9T1 equals to 1500. Now let's subtract those two to get rid of T2, and we get minus 25T1 equals to minus 1900. Now divide both sides by minus 25, and we'll get T1 equals to 76. Now from here we can find T2. Let's substitute it, let's say, somewhere, I don't know, here. And we'll get 4T2 plus 3 times 76 equals to 500. So we've got 4T2 plus 228 equals to 500. Then 42 equals to 68. 68 newtons and 76. Okay, question B. We have to find the greatest value of f for which the block remains in equilibrium. Now let's have a look at the picture. So the force F is acting to the right, and if the block is just about to move, means it's going to go in this kind of direction. So basically it will move a little bit upwards. And at the point when the block is just about to move up, the string, this one, will become loose. So that means T2 will be equals to 0. And now we can rewrite our equations knowing that T2 equals to 0. So on the x-axis we'll have f minus T1 cosine beta still equals to 0. And then on y-axis we got T1 times sine beta minus 100 equals to 0. Now let's substitute cosine beta and sine beta into this equation. So got 4 minus 4 T1 over 5 equals to 0. And the second will be 3 over 5 T1 minus 100, again equals to 0. Now from the second equation we can find T1. That will be 500 over 3 And we can substitute this into the first one. So we'll get F minus 4 over 5 times 500 over 3. That equals to 0. Now rearrange it to find F. That will be 4 times 500 divided by 5 times 3. And then all in all, it's 400 over 3, or it could be 133 newtons, correct to 3 significant figures. Okay, next question is about the power. So we got the cyclist, and we know its velocity. So we're looking for the power, that will be the driving force times velocity. And we know velocity is 4, so it's going to be 4 times the driving force. Now all we have to find is the driving force. So let's say that's a bicycle, and we got the driving force, and we also have the force of resistance, which is 30 newtons. And no other forces are acting on the bicycle. So the sum of all forces, which is driving force minus 30, should be equal to mass times acceleration. So it's 70 times 0.4. Oh no, 0.3. And from here, we can find the driving force, which is 51 newtons. Okay, now substitute it into the power. So power equals to 4 times 51, which is 204 watts. Okay, now next question. The cyclist comes to the hill. Angle is 5 degrees. Then over the distance d, the speed changes from 6 meters per second to 12. And there is still the force of resistance. But now the cyclist is not producing any power, so therefore no driving force. Okay, question 1 is to find the change in kinetic energy. So that's going to be kinetic energy final minus initial. So mv squared over 2, m is 70, the final speed is 12, minus 70 times initial speed is 6. That will be equal to 3,780 joules. Okay, for the next question, we'll have to find d, and let's look at the diagram first. So distance is here, d, and we're going to use energy method, so we're going to use the height for using mgh, of course. Now this height is opposite of the angle 5 degrees, so h is going to be d times sine 5 degrees. Okay, now, in this point, initially, she has kinetic energy and potential energy. And this energy is going to be mu squared over 2 plus mgh. Now, this energy is going to be transferred to energy at the final point. And at the final point, we don't have any potential energy. So it's only mv squared over 2. And also the initial mechanical energy is going to be transferred to do some work against the resistance. So I'll say plus work against the resistance. We know that h is going to be d times sine 5 degrees. The mass is 70 times g 10 times d sine 5. That's my mgh, and I will move mu squared over 2 to the other side. So I'll get mv squared over 2 minus mu squared over 2. And that's the change in kinetic energy. And we calculated this previously. It's 3,780. And now we have the work done against the resistance. Now, the work equals to force times the distance. So the force is 30, and the distance is d, the one we're looking for. Okay, now let's move 30d to the left side, and we'll get 700 d sine 5 minus 30d equals to 3780. Now on the left side, let's factorize. And now we can divide by the brackets to get d. And then d equals to 122 meters, correct to 3 significant figures. Okay, next question, we're first given that both planes are smooth, so there's no friction. And we have to find the tension in the strings and the acceleration. Okay, so first let's draw the forces. So looking at the particle Q, it is being pulled by the strings, so tension is that way. And looking at particle P, the string is pulling it up, so tension acts upwards. Now the weight of particle Q is 2 newtons. The weight of particle P is 3 newtons. And let's choose x and y axes. So for the particle Q, I will choose it this way. Y is upwards, and then x is going to be that way. For the particle P, y is this way, and then x is going to be down. Okay, now we can write the second Newton's law for both particles. So for particle Q, we'll have t, and then the weight, and then for the weight, we're going to use the x component. So this angle here is 30, so it's going to be 2 sine 30, and that must be equals to mass times acceleration. Now for the particle P, now tension acts in the opposite direction of the x-axis, so it's minus t, but then plus 3 sine 60, and then again that equals to mass times acceleration. Now let's solve these simultaneous equations. Okay, let's add up those equations to get rid of t. And now to find a, we're going to divide everything by 0.5, and we will get 7.196. And let's substitute this into the first equation. So t equals to 0.2 times 7.196 minus 2 sine 30, and that gives me 0.439. Okay, now let's round our answers to 3 significant figures. A equals to 7.20 meters per second squared, and then t equals to 0.439 newtons. Okay, next part of the question, we're given that there's a friction between particle Q and the plane. Let's say the coefficient of friction is going to be mu. Okay, and now let's say if the whole system is going to go downwards, then the force of friction will try to prevent this motion, so the force of friction will act up. And again, let's choose x and y axes. This time I will choose x to be upwards. And let's now write the second Newton's law for both particles. Now let's start with the particle Q. On the x-axis, we've got the force of 3 newtons. Acting up, we also have force of friction with the positive sign, and we also have the y component, the x component of the weight, which is opposite direction of x-axis, so it's going to be minus. The weight is 2 newtons, So it's minus 2 sine 30. And we also have tension. So minus t. Now it's equilibrium, so it equals to 0. Now on y-axis, we've got the normal reaction. And we also have the y component of the weight, which is adjacent to the angle of 30, so it's n minus 2 cosine 30. That also equals to 0 because of the equilibrium and because the particle is not moving on y direction. We also know that the force of friction will be the coefficient of friction times the normal reaction. So from the second equation on y-axis, we know that the normal reaction equals to 2 times cosine 30. So all in all, force of friction will be 2 mu cosine 30. Now let's substitute it into the top equation and we'll get 3 plus 2 mu cosine 30 minus 2 sine 30 minus t equals to 0. Okay, now let's have a look at the particle P. Here's everything a bit easier. We got the force of tension, and then in the opposite direction acts the x component of the weight. So it's going to be minus, the weight is 3 newtons, so it's t minus 3 sine 60. That equals to 0, and from here we can find t. And substitute it into the previous equation. And we'll get 3 plus 2 mu cosine 30 minus 2 sine 30 minus 3 sine 60 equals to 0, and from here we can find mu. So mu is going to be equal to 2 sine 30 plus 3 sine 60, take away 3, and all of this divided by 2 cosine 30. And that will be equal to 0.345. Okay, that's the answer. Okay, next question. We're given the formula for the velocity, and we know that velocity at t equals to 5 equals to 0, so let's substitute this straight away. V of 5 is going to be 9 over 4 plus b over 36 minus 25c equals to 0. And now we're also given acceleration at t equals to 5, and to find acceleration we'll have to find a derivative. And before we do that, let's write the formula using negative indices, like that. And now it's easier to differentiate. A is going to be equal to minus 2b times t plus 1 to the power of negative 3 minus 2ct. And now let's substitute t equals to 5, and we'll get minus b over 108 minus 10c, and that should be equal to minus 13 over 12 according to the question. So here's going to be our first equation, and that's going to be our second equation. Now, first of all, let's rearrange them. So we got b over 36 minus 25c equals to negative 9 over 4. And for the second one, we'll get b over 108 plus 10c equals to 13 over 12. Now, I want to get rid of c in those equations, so I will multiply the second equation by 2.5. Then I will get 5b over 108 plus 25c equals to 65 over 24. And now I can add them together, the first equation and this one. So I will get 11b over 216 equals to 11 over 24 Now divide both sides by 11 over 216. And we'll get b equals to 9. Now we can substitute this into the very first equation, and we'll get 9 over 4 plus 1 over 4 minus 25c equals to 0. And from here we can find c. So 10 over 4 minus 25c equals to 0, and from here c is going to be equal to 0.1. So let's keep this as the answer. Okay, for the next question we'll have to find a distance, and for that we'll have to integrate. So first let's rewrite the formula for the velocity. It's 9 over 4 plus 9 times t plus 1 to the power of minus 2 minus t squared over 10. Okay, now we're giving that velocity of p0 only at one point. And first I want to find the sign of v when t equals to 0. So I'll substitute 0 in there in the formula, so I get 9 over 4 plus 9 minus... Okay, that's it. Right, and that's going to be obviously bigger than 0. Then let's substitute t equals to 10, let's say. That's going to be 9 over 4 plus 9 over 11 squared minus 100 over 10. And that is obviously less than 0. Okay, so that gives us a very quick sketch of the velocity time graph, vt. So below t equals to 5, velocity is positive, and after it is negative. So that means we'll have to split our integration into two parts, first from 0 to 5, and then the second from 5 to 10. First let's find the integral without any limits, so it's 9 over 4 plus 9 t plus 1 to the power of minus 2 minus t squared over 10 dt. Then integral is going to be equal to 9 t over 4 plus 9 t plus 1, we get add 1 to the power, divide by the new power, so all in all it's minus. Next we get minus t cubed over 30. Now let's find its integral from 0 to 5. I will have to substitute the upper limit first, and then minus substitute the lower limit. So for the upper limit, I will get 45 over 4 minus 9 over 6 minus 125 over 30, and then substitute the lower limit with a negative sign to get 9. And all in all, that's 175 over 12. Now let's find the integral from 5 to 10. Again, we've already integrated, so we are substituting upper and lower limits here. Okay, starting with the upper limit, 90 over 4 minus 9 times 11 to the power of minus 1 minus 10 cubed over 30. That's the upper limit. Substitute the lower limit. It's 45 over 4 minus 9 over 6 minus 125 over 30. Now that gives me minus 2275 over 132. And then, as expected, this distance is negative because it's below t-axis, and the first one was positive. So now what I have to do is to remove the negative sign from the second integral and add up the first one. That is 350 over 11, or it equals to 31.8 to 3 significant figures. Now let's put this as the final answer, 31.8 meters. Alright, and that was the last question of this paper. I hope you find it useful, and I will see you next time. Bye bye.